Back in 2024, Microsoft had just unveiled their new super AI for chemistry, Azure Quantum Elements, and they were praising it to the skies. Their CEO, Satya Nadella, made a massive claim. He said, "This technology will help us compress the next 250 years of chemistry into the next 25." It was a big promise. And to prove it wasn't just hype, they needed a real challenge. They needed to solve a problem so difficult that no one could argue with the results. So, they teamed up with the Pacific Northwest National Laboratory and picked a target: the battery crisis. We all know the lithium supply chain is at a breaking point. It's expensive, volatile, and dangerous. We simply cannot mine it fast enough to meet demand, and the environmental cost is devastating. The industry has been desperate for a solid-state alternative that could swap out that expensive lithium for cheap, abundant, and safe sodium. But there was a reason nobody had built one yet. Chemists had struggled for decades to mix these two materials. The fundamental barrier is simple geometry. Sodium ions are significantly larger, about 35% bigger than lithium ions. When you try to force both into the same crystal structure, that size difference creates severe stress. It's like trying to fit a basketball into a hole meant for a tennis ball. The crystal just rejects it. Instead of mixing, the material separates, essentially refusing to homogenize. To solve this, Microsoft didn't rely on human intuition. They approached it as a massive data problem. They unleashed their AI to perform what's called combinatorial generation. Essentially, the AI swapped atoms in and out of known frameworks, generating a massive search space of 32.6 million potential materials. Now, simulating the physics of 32 million structures would take thousands of years using traditional methods. So, they used AI as a high-speed proxy. They employed graph neural networks to predict how these materials would behave, turning a task that should have taken lifetimes into an afternoon's work. Then, they started the funnel. First, they screened for stability. The AI calculated the energy of every candidate and instantly discarded millions that would just fall apart. That took the list from 32 million down to 500,000. Next, they screened for performance. They filtered for materials that could actually move ions around efficiently. That slashed the field down to just 800 candidates. But here's the catch. AI is probabilistic. It can hallucinate. It can tell you a structure is stable when it isn't. So, for the final phase, the team switched from the AI back to traditional computational methods. They used supercomputers to run rigorous physics simulations on the final 800 candidates, solving the Schrödinger equation to verify their integrity at the quantum level. The physics confirmed that out of 32 million options, only 18 actually worked. They synthesized the top candidate, and it worked. The secret wasn't just mixing lithium and sodium, it was the addition of chloride. The AI used chloride to hack the geometry. Because chloride ions are so physically large, they build a crystal lattice with huge internal voids. This created a shock absorber effect. The lattice effectively swallows the size difference, allowing the heavy sodium to sit comfortably in the structure without cracking it, while the lithium zooms through the open lanes. This one discovery slashes lithium content by 70%, turning a material that physicists said couldn't exist into a working reality.